problem. We must first split the summation into two parts. So that means that sigma of n k equals 1, k times k plus 1 is equal to the sigma summation of n equals k equals 1 of k squared, and the sigma summation of k. Since we know that the sigma summation of k is equal to n times n plus 1 over 2, therefore we need to find the value of the sigma summation of k squared. So first, we know that the sigma summation of k squared is simply equal to 1 squared plus 2 squared and so on until n squared. So therefore, let's also look at this identity. K plus 1 cubed equals k cubed plus 3k squared plus 3k plus 1. And we can see that it also has a k squared. So let's isolate. Therefore, we get that k plus 1 cubed minus k cubed is equal to 3k squared plus 3k plus 1. So now, let's take the sigma summation of both sides. So we get that the sigma summation of k plus 1 cubed minus k cubed, don't forget, equals equal to 3 times the sigma summation of n, k equals 1, of k squared plus 3 sigma summation of n, k equals 1, of k, and the sigma summation of n, k equals 1 of 1. So now, let's work with the left hand side. We can see that this is basically, let's insert our numbers. It's basically just 2 cubed minus 1 plus 3 cubed minus 2 cubed. And then you can see that it cancels out, plus 4 cubed minus 3 cubed. We can see that this cancels and so on and so on until n plus 1 cubed. Since this is minus n cubed, there will be the n cubed term before, which cancels this out. So therefore, on the left hand side, we are left with n plus 1 cubed minus 1 is equal to 3 times the sigma summation of k squared of n, and k is equal to 1, plus 3 times n plus 1 divided by 2 plus n. Okay, so now we can see that this turns into n cubed plus 3n squared plus 3n. See that this is n cubed plus 3n squared plus 3n is equal to 3 times sigma of k squared, and then this is 3n times n plus 1 plus 2n divided by 2, or this simplifies to 3n squared plus 5n divided by 2. So now we can see that. So now let's move to the other side. N cubed plus 3n squared plus 3n minus 3n squared plus 5n divided by 2 is equal to, let's just put that later. So now we need to times 2 on both sides to remove the fraction. So we get that 2n cubed plus 6n squared plus 6n minus 3n squared plus 5n equal to 6 sigma summation of n k equals 1 of k squared. So now we can subtract both sides, and we get that it becomes 2n cubed plus 3n squared plus n is equal to the 6 times sigma summation of k squared. So now we can also divide by 6 on both sides. So now we get that the sigma summation of n k equals 1 is equal to 2n cubed plus 3n plus n divided by 6. But you may realize that this hasn't been simplified yet. So now let's simplify it by splitting this up, splitting the 3n squared up to n cubed plus 2n squared plus n squared plus n. So now we can see that this factors out into 2n squared n plus 1 and also plus n times n plus 1. So we get that this is n squared plus we get 2n squared plus n times n plus 1. So now this also has 2 n's in it, so we can factor it out, and we get that n times n plus 1 times 2n plus 1 divided by 6 is equal to the sigma summation of k squared. So now that we have the value of k squared, we can go back to our original problem. Sigma n k equals 1, k times k plus 1 is equal to the sigma of k squared plus sigma of k. Wait, so now we just plug in the values n plus 1 and then 2n plus 1 divided by 6 plus n times n plus 1 divided by 2. And we can see that they are both similar, since they both have n times n plus 1 divided by 2. So now we can factor it out from both sides. N times n plus 1 divided by 2 times, times like this, 2n plus 1 divided by 3 plus 1. Now we can simplify. We can move the 3 to the upper side. So now this becomes plus 3 and this becomes 2n plus 4. So now we can also factorize the 2. So this becomes 2 times n plus 2, 2/3 of n plus 2 times n plus 1 divided by 2. And the 2's cancel out. Therefore, we have proven that the sigma summation of n k equals 1 of k times k plus 1 is equal to n times n plus 1 times n plus 2 divided by 3.